Alright, here's your help video for quiz 3.08. Now in class, if you haven't seen this already, we're going to be creating this in class. But I just wanted to put this up here because these are the ways to tell if triangles are congruent. You can use side, 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 angle, side, angle, hypotenuse, leg, side, angle, side, angle, angle, side. Those are the 5 ways. These are the ways that don't work. Angle, angle, angle doesn't work. Angle, side, side, or side, side, angle, either the dirty word or the wordy dird. Those don't work. And then if you have things that just don't even match up, like a side angle side with a side, 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 those aren't going to be congruent. They have to match. Alright, so that was a quick refresher. Let's go ahead and look at this one. Which angle is the included angle for JL and KL? I'm going to go ahead and highlight these. JL and KL. And once you highlight it, I think you can tell that the angle that forms, or the angle in between those two sides, would be angle L. You could also just kind of look up here. Notice they both have the letter L, so L is going to be the included angle. Alright, so which postulate or theorem proves these two triangles are congruent? Okay, so first we need to be able to see which two triangles we're talking about. So we have triangle FGJ, and then we have triangle JHG. Alright, so those are our two triangles, and then let's look at the markings that were already given. Okay, so for the yellow triangle, we're given an angle and another angle. For the green triangle, we're given an angle and another angle. So we have 2 angles, but we need at least 3 things to prove that they're congruent. So that's when we head down to this helpful hints page. If they share a side, that's a reflexive side. If they share it, it's going to be congruent. So if you look over here, both of these share side JG. That means they both have the same side length right there. So if we look at our yellow triangle, we have an angle, and a side. And then if we look at our green triangle, we have an angle, and a side. And so we can prove that these are congruent using angle, angle, side congruence postulate. Let's check out this one. Which postulate or theorem proves that triangle RMN and QPN are congruent? Alright, so again, let's go ahead and color code our two triangles. I'm going to do one triangle green, and I'm going to do the other one purple. And then let's look at the markings that we already have. We have an angle and a side in the green triangle. And in the purple triangle, we have an angle and a side. But again, that's not enough. We can't just have an angle and a side. We need more information than that. So we go back over here to our helpful hints page, and this falls under the category of vertical angles. Remember, you can remember vertical angles as kissing V's or as bow ties. But if you have 2 intersecting lines, line PM and line RQ, those intersect, they form vertical angles, and the vertical angles are always congruent. That's something that we talked about a few lessons ago. So I'm going to go ahead and mark that this angle is congruent to that angle. And now if you look at your green triangle, we have an angle, side, angle. And in the purple triangle, we have an angle, side, angle. So we do have enough to prove that these are congruent using the angle, side, angle congruence postulate. Alright, so which postulate or theorem proves that these two triangles are congruent? So again, I'm going to go ahead and color code them. I have the purple triangle, and I have the blue triangle. So a couple things. If this is 90 degrees, we know that this is also 90 degrees because those form a linear pair. So they have to add up to 180. And then we're given that this side is congruent to that side. So if I look at the purple triangle right now, I have a side and I have an angle. But that's it. And if I look in the blue triangle, I have a side and an angle. But I have to have at least 3 things to prove that they're congruent. So since I'm missing a marking, I'm going to go back to my helpful hints page. And this one's going to be the reflexive side, right? They both share side EF. And since they both have the same side, I know that it has to be congruent. EF has to be congruent to itself. So now in the purple triangle, I have a side, an angle, and a side. And in the blue triangle, I have a side and an angle and a side. So I do have enough to prove that they're congruent using the side, angle, side congruence postulate. Now don't get confused. Sometimes whenever people see a right angle, they automatically assume that it's going to be hypotenuse leg. But we have no way of proving, until we've already proven that the triangles are congruent, we don't know that these 2 hypotenuses are congruent. So don't jump straight to that just because you see a right angle. We can actually prove that these are congruent because of side, angle, side. And then the last one. Again, which postulate or theorem can be used to prove that they are congruent? All right, so let's go ahead and color code. We have a blue triangle and a green one. And so far, if I look at the blue triangle, I'm given 2 sides, and the green triangle, we're given 2 sides. So far we have side, side. We need one more piece of information. Well, again, we're going to go to our helpful hints, and this is going to be the reflexive side. They both share side AC, so I know that that has to be congruent to itself. AC has to be congruent to AC. And so now each triangle has side, 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 so they are congruent based on the side, side, side congruence postulate. Hope this helps. And I'm going to end it on this page in case you need to just look at those postulates one more time.